So for 55, we are taking an elliptical region that has a boundary curve of this equation. So I'm just going to draw in here some axes. So that's my z, this is my x, and that's my y. These are going to continue like so. Okay, and let's think about how we're going to draw this ellipse. So the equation for the ellipse is 9x squared plus 4y squared is equal to 36. And the equation of an ellipse is basically x squared over a squared plus y squared over b squared is equal to 1, where a and b are the axes. So we're just going to divide everything by 36 so we can have 1 on the other side. So we're going to have here x squared over 4 plus y squared over 9 is equal to 1. And then we're taking the square root of that to get a and b. So we have 2 is equal to, that's going to be our minor axis. That's going to be on the x, right? Because it's the square root of 4. And then 3 square root of 9 is going to be our major axis. That's on the y. So let's draw that in. On the y, we're going to have 1, 2, 3 on this side, and then 1, 2, 3 on that side. That's our major axis. And on the x, we're going to have 1, 2, and then 1, 2, our minor axis. So now all we have to do is connect these dots to form an ellipse. Yeah. And then it's telling us that the cross sections perpendicular to the x-axis. So let's draw these perpendicular to the x-axis. They're going to be like this, perpendicular to the x-axis. And then it's telling us that it's going to be isosceles triangles with hypotenuse at the base. So we're going to sum up these triangles like so. Yeah. So whenever we're adding these triangles, and we're adding them from positive x over here all the way out to negative x, right? And then we're summing up all these triangles, and when we do so, it is going to give us a volume. Actually, I drew these quite poorly, so maybe I'm going to erase that. Yeah. I'm going to just draw a single cross section that goes from here to here, right? And then it is an isosceles triangle. That's a 90-degree triangle, so like so. Yeah, and then we're summing them up on this direction. We're summing them across the x-axis to get a volume. So our integral here, because this is an ellipse is symmetric about the axes, instead of going all the way from, because this is 2 and that's negative 2, right, because of the axes, instead of going from negative 2 to positive 2, we're basically going to go 2 times from 0 all the way to positive 2, because we're summing them up across the x-axis, and then we're just doubling from 0 to 2 so that we can have an integral that's easy to compute. Okay, now let's think about how we're going to sum up these triangles, right? So these triangles, when we add the area of each one, it's like this. I did not draw this in a great form. So this is our hypotenuse, right? And this is our base. So because these are isosceles, that's base height, and then that's our hypotenuse. So our area here is base times height divided by 2. Well, the height is the same as the base, right? They're equal because it's an isosceles. So our area is basically base times base divided by 2. So our area is b squared over 2. All right, so now let's think about this hypotenuse. Well, this hypotenuse here, we're going to have the Pythagorean theorem, right? So we're going to have that b squared plus b squared is equal to h squared, and therefore h squared is equal to 2b squared. And let's just think about what this h is. Well, it's interesting to see that this h here is basically twice the height of the function, right? The height of this ellipse. Because if we look this way, the height goes from 0 all the way out to y, and this is half of it, because the other half goes from 0 from negative y. So basically, this height here is twice the value of y. So basically we say that, okay, h here is 2 times whatever the value of y is 2y, right? And therefore h squared is equal to 4y squared. So now we can substitute this back in and say, okay, 4y squared is equal to 2b squared, and therefore we have here that y squared is equal to, if I divide everything by 4, b squared over 2. Okay, that's nice for us, right? So b squared over 2, and then we have an expression that is in terms of y. So to finish it off, let's express actually this. If y squared is b squared over 2, then let's just join these into a single expression for area, right? So I have here that my area is b squared over 2, so my area is going to be y squared over 2 over 2. So actually I'm going to do it the other way. 2y squared is equal to b squared. Yeah, that way it's easier. So therefore my area is equal to, let's see, that is 2y squared, b squared over 2, and therefore area is equal to y squared. So even I took the long-winded way, but hopefully that made sense for you guys, because here I was just expressing y squared in terms of b out of this area, right? Because the base here is related to the height of the function, and then since the area is b squared over 2, I just express it in terms of y squared. Okay, and now that we have this, let's finish this off by tying it into our original equation, because y, it's not just y by itself. Y follows the path of this ellipse, right? So whenever we have, we can express y squared in terms of this whole equation of the ellipse so that we can follow the path. And let me do this in a different color. And therefore here, let's see, we have that 4y squared is equal to 9x squared minus 36. Let me see if that is correct. No, that should be minus 9x squared plus 36. Therefore, y squared is equal to minus 9 over 4x squared plus 9. So nice. Now that we have an expression for y squared and then we have an expression for the area, we can see that these are the same, and we can basically, we can sum it up. Because remember that we're just summing up the integral of ax dx, right? And the area is y squared, and y squared is this whole thing right here. So let's put it back into our equation. So we're summing up, let's see, we're summing up minus 9 over 4x squared plus 9, all of this times dx, because we're summing it up horizontally across the x-axis. And so this is going to give us twice times minus 9 over 4x cubed over 3, and then plus 9x, and all this evaluated from 0 to 2, which is going to give us, let's see, 2 times, let's put this in, 18. That is going to give us minus 6, because that's 8 divided by 3, and times 9, so that's 24 divided by 4 minus 6, yeah, plus 18. Which in the end is going to give us 24. So yeah, that's the volume that we get when we sum up these triangles all the way from negative, or in this case twice, from 0 to 2, right? And just thinking that these triangles, the base here is twice the value of y, and the value of y follows this curve here of the ellipse.